We're going to look at graphing quadratic inequalities, specifically greater than inequalities. So let's have some fun in this one. So if we're going to graph x plus 2 times x minus 3 is greater than 0, we'll get the domain later. When we graph this, we know that if we want it to be greater than 0, then these two x's have to be positive. Okay? So there's two different ways to do that. You can have a positive, okay, times a positive, right? Or a positive, they use the word and a positive. Or you can have a negative and a negative, right? Because a negative times a negative would equal a positive. And since we're trying to be greater than 0, then that means we need overall a positive number. So hopefully you caught on there. So what we're going to do is isolate each of these two expressions, and if it's positive, we want x plus 2 to be greater than 0. We want it positive, so we want it greater than 0 if we're satisfying a positive equation. So we want x minus 3 greater than 0. Let's just solve this side first. So when we solve, it'd be x is greater than, after you subtract the 2, negative 2, and x is greater than positive 3. Well, only one of these satisfies it being positive. This one would not work because x cannot be negative. It leaves a chance for x to be negative, and that would not work. So x is greater than 3 is one solution. Now we got to look for another solution. So now we're going to take the x plus 2 and the x minus 3, but since we need a negative times a negative for the x, we need to do less than 0 on both. Less than 0. Here, I'm going to move this one out of the glare. Need a less than 0. We're looking for a negative. So we solve and get x is less than negative 2 when we subtract negative 2. All right, and then we get x is less than a positive 3. Well, remember, we need a negative solution, so x is less than negative 2 would satisfy that. So these two satisfy what we are trying to do. Okay, if we're doing a positive times a positive, it's greater than 3. The two numbers for x, or whatever we plug in for x. If we're doing a negative times a negative, we would know that x would have to be less than negative 2. So now we simply graph that number line. This part's easy. Well, then I mess up. Okay, greater than 3. We find 3, open circle. Since it's a greater than sign, shade to the right. And then we find negative 2, shade to the left. And that would be how you graph x plus 2 times x minus 3 is greater than 0. And it was real numbers for our domain. So therefore, everything shaded in between would be there. If it was integers, I would have to fill in dots. But that's not the case. So that's how you shade, that's how you graph that one. Let's look at one more example. Example 2 makes it look a little bit different. X squared minus 2x is greater than or equal to 3. Yes. X squared minus 2x greater than or equal to 3. And your domain is just integers. Okay? So once again, oh, well, actually, before I start, I need to solve to get everything on one side. I need to get 0 over here. So I'm going to subtract 3. So that's x squared minus 2x minus 3 is greater than or equal to 0. Now, from this point, what I need to do is I need to factor. Is there anything that multiplies to be negative 3 and adds up to be negative 2? Yes, that would be x minus 3 times x plus 1 is greater than or equal to 0. So now we have it in our factoring form. So now we can get to graphing. So once again, We need it greater than, so we're doing a positive and a positive, or we are doing a negative and a negative. So let's start with the positive and positive. X minus 3 has to be greater than or equal to 0. And then x plus 1 has to be greater than or equal to 0. Since we're doing positive numbers, it's got to be greater than 0. So we add 3, so that becomes 3. Subtract 1, so that becomes negative 1. This is the only one that would satisfy the positive solution set. So we can erase that one. Now we're going to the negative. So x minus 3 has to be less than or equal to 0, since we're doing a negative. And then x plus 1 has to be less than or equal to 0. So we add 3. Oops. Did I do that right? Yeah. Yeah. Add 3. Subtract 1. So the only one that actually satisfies it being a negative number is this one. So those are our two solutions sets. Now I make my number line. Okay, I'm going to start with circling in 3, circling in negative 1. Now our domain is integers. So I can't just shade, we're going less than, I can't just shade this way. That wouldn't work. I got to fill in circles. Now, yes, this keeps going on and on and on. We're going to stop right there. And greater than or equal to 3. Okay, and that keeps going on and on and on that way for integers. But we can stop there. But that would be how you graph quadratic inequalities.